All right. Wow, big crowd. Really appreciate you guys coming out. My name is Casey Stella. I'm with Hortonworks, and I'll be talking to you today about IPython Notebook as a unified data science environment for Hadoop in particular. All right, we'll talk about some preliminaries, then we'll talk about data science in Hadoop, and what it is that I mean when I talk about a unified environment, right? And then we'll look at a demo, and then some Q&A. All right. So I'm a principal architect at Hortonworks. My focus has been primarily data science. So that's hence me talking to you about a unified data science environment. I work in the consulting organization, so I do day-to-day, I do data science. So prior to this, I was at a clinical informatics startup called Explorers that was spun out of the Cleveland Clinic, doing architecture and data science with them. I did some signal processing and scientific programming in the oil and gas industry, and I was a graduate student at Texas A&M, so go Aggies. All right, so data science in Hadoop. Hadoop's a great environment for data transformation. We see that all the time. You know, you look at the Gartner report and you see them talk about use cases about EDW, offload, and ETL. And it does very well at that. Data science, as a data science environment, it can pose some challenges. I'm optimistic, and I think it's a fantastic data science environment, but it is a delicate line to toe. A single system where both data transformation and data science can be expressed, or the algorithms themselves can be expressed naturally, can be very challenging. It's actually it's slightly more complicated because it's not a direct line there, right? There's ETL to get to the point to where you can do data science, but once you're at the point where you're doing data science, there is further transformation, right? We just call it feature extraction often, and sometimes that's challenging. So the transformation doesn't really stop. Right? It goes all the way from before it hits the data scientist all the way to the point where you're doing the data science. It's part of the data science. Right? The other big challenge, I think, is popular languages for data science with mature external libraries don't coincide often with JVM languages. And this isn't a dig against Scala or Java at all, because I do data science largely in Java and Scala. It's just that for the most part, you talk to data scientists on the ground that I see at customer sites, and I say, well, you can use Commons Math, and they say, what? So they say, no, I want to use R because it has the full force of a legion of graduate students to make sure that it is at the tip top, most current. I want to use Python because I like to use Python, and I've been doing prototyping in Python, and I like scikit, and I like NumPy, and all these things. So it can be challenging. Up until this point, up until recently, Hadoop has been challenging to interact. I think that's changing, and I think that's changing for the better. It's not entirely there yet, I would say, but it's very, very close. So, but. Also, a system to represent the output of data science and analysis, just summaries and visualizations. So this sort of represents, these three challenges represent the data in, the processing, and the representation. Data science without communication just falls flat, right? It's like an analytic that no one uses. It can be the best analytic in the world, it can be the best statistic in the world, but if no one uses it, if no one acts on it, if it's not actionable, then it's useless and you've wasted your time. Other than it's fun to do, probably. I mean, I like it, but it'd be even better if it could be communicated to people with money who can make sure that they can, act on it. The other thing is, you could talk about simplifications and tools that simplify the visualizations, right? The commercial tools like Tableau, et cetera, and these are great. There's certainly a place for them, but often I find myself, just for my own purposes, needing to visualize things. Like I need to visualize distributions a lot, and you'll see that. Like the visualization actually helps you understand the data, which helps you do the data science, and also you have great fodder for creating PowerPoint decks, which I do sometimes. Very poorly. So it's elusive, but I think we have a great start with the Python bindings in Spark and IPython notebook, or notebooks in general. So you've heard a lot thus far about Zeppelin and other notebooking environments. So this talk is largely, you can take these things and translate them from IPython to notebooks in general. There are challenges there too, but I think that this is kind of the way forward, in my opinion. This is how I like to work, at least, and I'm opinionated. So what are the components of a unified data science environment? So it's a single environment that supports mixed mode, local, and distributed processing. So what does that mean? Those are words that might not have full impact. It means that up until this point, you write MapReduce jobs, and you end up doing everything is distributed. You write your mapper, you write your reducer, right? You maybe some streaming jobs, maybe use RMR, whatever. A lot of times, you actually need to do things like do distributed analysis, aggregate, pull the data down, and then do further analysis on the aggregated data. If I have to leave the tool that I'm doing, I have to do the distributed analysis, stage the data in Pig or Hive, and then hit it with another place. That's me having to do a context switch, which I hate, having to do context switches, and I like to minimize them as much as I can. But so what I mean there is you need to be able to seamlessly interact with in a distributed way and a local way in one environment. And I think Spark has a really great API and really great semantics for doing that. You have to reach out to the languages with heavy data science support. I don't want to recreate the wheel, right? I don't want to recreate an algorithm that I would like. I don't want to recreate algorithms in scikit-learn if I don't have to, right? Or NumPy, et cetera. And I think the Python bindings are a great story for that. And the other thing is strong, seamless SQL integration. So I think data science is largely, so where SQL fits in my opinion, is SQL is a great query language, right? If I need to refine my data, if I need to project certain things out, I need to join things together, join tables together, I can do a lot of that in SQL, and then I can take the output of that while it's still distributed, and then process it further. And that's super powerful, I think. And I think Spark SQL is actually a really powerful story there. The ability to visualize and report summary data, right? Just to understand the data. And I think IPython Notebook is quite good at that. It sits right after I'm writing custom Python and a shell script, and right before I'm using a point-and-click utility, right? I can write simple functions to do the normal charts and distribution plots and things like that I want to make it really quite easy to use and build up libraries of those. Okay, so you probably all have heard of Spark. I'm not going to go too deep into what Spark is, but I do like to to kind of give a summary of how I view Spark. I like to think of Spark as one of the best APIs that I've seen in quite a while. It's elegant, it's rich, and it's very usable as a core API. Also, it has an expansive set of ecosystems that are relatively high quality, I would say, and that can be very challenging in any open source software, any software in general, but I think they've done a fairly good job of that. Built around the core API. They've reached out and integrated well. They have Hive compatibility with Spark SQL. It's not a separate thing. So if your organization stages its data in Hive, like a lot of the ones that I've interacted with do, you can interact with that in the same way that you can interact with it in Pig. So it's a full player, I guess, in that environment. Mature Python support for the core APIs, as well as the Spark ecosystem project. It was the first one that I really saw outside of just running streaming MapReduce jobs that really supported CPython. A lot of the Python integration before was JPython, or Jython, I should say. And that's great if you just want to write, if you're comfortable writing user-defined functions in Python. But if you want to use some of the more interesting libraries out there, you couldn't do it. It was a challenge. They really did a good job of supporting that, and also adopting it as sort of a primary language, right? All the ecosystem projects also have Python bindings. It's not 100%, but it's there, right? You get you get most of the stuff, and you're assured that it will continue. If it's not in this release, if it lags Scala in this release, in Java in this release, it'll be there in the next, right? So the core ideas are data sets are distributed and resilient, so RDDs, so-called RDDs. And this becomes important in the mixed local distributed mode of computing, right? So you can run SQL queries, you can take the output of that, that's an RDD. It's not going to necessarily, if it's a large amount of data, it's not going to stream all local. And then you can further refine with Spark if it's difficult to represent in SQL. Data sets are automatically rebuilt on failure. It has configurable persistence. You can do caching. It uses memory. You can develop working sets and things like that. Transformations are parallel, and you have a further expansive set of transformations that include relational primitives, which I think is a really nice. It's a really nice place. I think it's it's a step beyond MapReduce and right before a lot of the relational-oriented domain-specific languages like Pig. That's not to say that I think that Spark is going to replace Pig for ETL. I think I'm a big Pig lover, so also I think they both have their place. All right, so it supports standard CPython as well as the core APIs as well as MLlib. So this is going to be kind of an odd talk. You're going to see a data science talk that involves Spark and doesn't use MLlib. You probably will see a lot of them that do use MLlib, but I'm actually not going to be using that. This is just going to be core Spark. So an IPython notebook support comes out of the box. It was the first notebook that was really supported. Okay, so it has integrated APIs with Python, Scala, and Java, as well as allowing you to integrate the core APIs with SQL. So you can start and stage your data in SQL, and then further refine your data with the core APIs, right? You could do maps and reduce by key, and you can do groups and joins, etc. beyond that. And the reason why that's important is oftentimes you find that it can be very challenging to represent complex joins in SQL, right? And if you could mix some of the Spark core with getting 80% of the way there in SQL, then that would end up with a lot more of a readable query, I would say. And because you can seamlessly call Python functions from the core API, you can do a lot more. You can essentially use it as a UDF. And Hive metastore integration, I think, is quite important. Okay, so. Beyond that, I wanted to talk to a little bit about show an example starting from sort of the beginning of a data science environment. So of a data science project. The first thing that you do in a data science project is generally understand the data. If you are going to be successful, you have to understand the data first. So we'll actually look at some open data. It's called open payments data. So doctors and hospitals have financial relationships with healthcare manufacturing companies, and as part of the Social Security Act, there was a requirement that these financial relationships be reported and quantified at a very detailed level. So if a doctor is getting consulting fees from a pharmaceutical company or a medical device company, they have to report that. And it's an open data set. And I thought, this is very rich, and very few people are looking at it, it seems. I saw one article from the Wall Street Journal talking about some anomalies in it. So I thought, this is great to look at, if we could look at anomalies and fraud analysis on this. Kind of a dull blade exercise. I'm not calling out doctors as being fraudulent. But can you see some things can we look at this relatively small data set, something that fits inside of a notebook or a sandbox VM from Hortonworks. We can run Spark on it and see, because this kind of stuff is going to scale out, right? Okay, so let's use Python and Spark and IPython notebook to explore this data set a little bit. Okay, so I'm not going to run the notebook itself because I'm running it on a VM, so the queries take slightly longer than one would hope for a public talk, but you can see the kind of things that we're doing. Right? Okay, so we're using, so the importance here is that we're using the full set of the Python ecosystem, which is quite extensive, right? There's NumPy, there's Pandas, there's SciPy, there's as well as Matplotlib for visualization, as well as PySpark with the SQL integration, and Seaborn for visualizing distribution plots. So the first thing that we do is once we develop a set of libraries to make visualizing this data easier, so I don't have to futz around with Matplotlib each time. I can solve it once and reuse these functions. So we have functions to print a bar chart, print a table, sort of pretty print a string if it's too long, etc. So first thing we're going to do is the first part of this is really data investigation. Right? I mean, I know this is a data science talk and you didn't come for data investigation, but that's part of every data science project is understanding the data. So let's get a sense of how many rows there are, right? We're looking at 2.6 million transactions, or 2.6 million connections between payers and doctors, or physicians, I should say. Which is a lot of data, but not a ton of data, right? Just enough to analyze. So we can look at, we can do simple SQL to see the number of payments per reason. So the way the data set's set up is there's the doctor and the payer and the reason and the amount, right? So pretty simple set of criteria. And by the way, all this data was pre-processed and ETL'd in Pig and staged in Hive. That's the way that so if I'm playing a data scientist, that's the way I would expect the data to be gotten, mostly because that's been my experience and how people have done that. So we see a lot of food and beverage purchases, or a lot of food and beverage payments. So food and beverage by far dominates. Next is travel and lodging and education. So kind of down here is gifts and consulting fees, which is which are the ones that if you're looking for fraud, kind of I wanted to zoom in on, right? The gifts, which I thought was kind of neat. Okay, so if we look at the doctors, which specialties are getting reimbursed, are getting the most reimbursements? Family medicine, internal medicine, those are right up there. But if we start looking at which specialties are getting the most reimbursements by sheer amount, you see orthopedic surgeons are bubbling right to the top with a lot of money, $80 million over. This is over 1 year, right? Which is so they're dominating. So why is that? Orthopedic surgeons, first off, there are a lot of sick people, right? The baby boomers are getting sicker, and they often will break their hips. Osteoporosis is really bad, things like that. So what'll end up happening is there's a lot of demand. So, and also it's a specialty that has a high likelihood of having patents and getting consulting fees and things like that, because it's sort of at the intersection of medical devices. So a replacement hip would be a medical device, things like that, right? Oddly, the thing that I did find odd was psychiatry and neurology was high up there in both number and amount. It wasn't super dominant, but it was up there. So now we get a feel for kind of what the data looks like and how this stuff is distributed. One thing I wanted to figure out was, well, that's great, but if we stop there, all we have an idea of is kind of a rough rule of thumb about how this stuff is distributed. I have no idea whether or not it's reasonable or unreasonable that orthopedic surgeons are getting paid that much. Are it reasonable or unreasonable that there are, X number of gifts? What we really want to do is look at outlier analysis. And actually, I was really shocked when I came here. There are like 3 or 4 talks about outlier analysis. This evidently is a big thing. And you see it in the field, right? You do a lot of outlier analysis. You really want to see what's odd, right? And a lot of people do really complicated techniques, right? You'll see things like, support vector machines. You'll have a 2-class support vector machine, and to kind of find odd values and things like that. And or you'll find, I think last year Ted Dunning did a talk about using semantic hashing to do outlier analysis. All that stuff I think is overthinking it, actually. I think that we need to pull our intuition from the people who've been doing data science forever, which is the statisticians and the industrial engineering industry, and just statisticians in general. And you'll talk a lot about, so what I was looking for was a relatively simple technique to find outliers that was a little bit, that did not assume just a normal distribution. So one of the things that I did, so one thing that you should gather from the analysis done before, one of the things I was looking at was, how is this stuff distributed, right, by specialty, right? And it has a long tail, right, for the most part. So what I wanted was an outlier analysis technique that was relatively simple, easy to explain, and did not assume a normal distribution, which a lot of them do. So normally you'll see things like, well, you look at this many standard deviations from the mean, and if it's beyond that, then it's an outlier. Instead, I wanted to go one step beyond that and use median absolute divergence. So it's sort of the standard next step there. What it does, and it's in the official engineering statistics handbook from NIST. Right, from the government. So it's been around forever, and I actually like it quite a lot. So unfortunately, LaTeX it's not parsing, but the idea is that you look at, if you look at actually, let me just refresh this real quick so it parses. I believe I have internet connection now. Sorry about that. Okay. So given univariate data x, which we do have univariate data, if x twiddle is the median absolute divergence of x is going to be the median of the distance of each point from the median, right? So that's a little bit weird. Essentially what it is you use this to normalize the data, and you develop just the same kind of z-score that you would normally with any test, any statistical test, right? You develop a z-score with this normalized data. And the idea is that this should not assume normality. So what we're going to do is we're going to actually implement this directly because it's very simple to implement. The challenge is it is somewhat computationally intensive because that median can get challenging. If I were doing this in production, I would probably do something like a streaming median, right? And that would be a better approach to that. But for clarity's sake, we're using just a regular median. So we have some helper functions here. The ability to sample, very simple. But you see most of these are very small helper functions. So the first thing we do is we're going to project out with a simple SQL query, actually just the fields that we need. And then we're going to go directly from the output of that into Spark functions. Right? So now we have an RDD, and this is all happening on the cluster. None of this is getting pulled locally. And we will call get outliers on this, which is the output of that SQL function before. So what we're going to do is we're going to group, instead of looking at outliers across all specialties, we're going to look for outliers within a given specialty across all reasons. Right? So what we'll do is at the end, we'll look at the worst outliers across all the specialties for the individual reasons. So we'll look at, who are the outliers for food and beverage, and we'll say, okay, across all the specialties, who are the worst outliers based on how far, how high was the z-score away, right? We'll rank them that way. Okay, so from this point, it's just Spark, but I want to point out that it's calling directly this function that was local right above. And if I had local data, I could use the local data in the function, median func, right? So if I wanted to say, for instance, pull in a streaming median, you could there, right? But the point is, that this is distributed computing and local computing. But one of the reasons why it's nice to use in Spark is because now I can group the data by reason and specialty, and then look for outliers in that group in parallel across. So it turns into an embarrassingly parallel problem. Right? And a lot of situations like outlier analysis do turn into embarrassingly parallel problems, because you may have petabytes of data, but if you slice the data in certain ways, you end up with many embarrassingly parallel problems. And I see that all over the place. Right? A lot of people go immediately to MLlib and these high-powered machine learning libraries that have a place, absolutely have a place, and are very important. But you should try to be you should be intelligent about how you look at the data. And can you take a large problem with a large amount of data into thousands of small problems with medium-sized data? Right? That's really the key here. Okay, so I'm not going to go through the actual implementation too much. You can see it's like 4 or 5 lines, honestly. It's not that intense, even in Spark. So what we'll do is we'll kind of look at the data. So I have a helper function here to display the data in a table and then look at the distribution. I want to look at the distribution of the outliers compared to a sample, just to kind of visualize how this looks. And so this is a visualization that can be reused in a PowerPoint slide and communicating to upper management, and can be interpreted, right? So first thing we're going to look at is GIFs, right? So we're going to look at outliers for GIFs, and they're ranked by how much of an outlier they are. What we're finding is if you look, there's a dental chair manufacturer giving $56,000 in gifts for one gift to a dentist. And you can see, there they are right there. That's a lot of money. That's a lot of dental chairs, I'll be honest. I don't know what kind of gifts they're getting, but, and you see, like, actually they by far dominate. Dentists are dominating all the outliers here. So if I took dentists away, then you get far more, kind of more interesting things, but you see this is particularly bad over here. I'd love to know what that gift was. I wish they had that in the data set. Need to call the government and ask. Okay. So moving on, obviously that's something that's weird that needs to be looked at. Is it fraud? Maybe not. Maybe it's bad data, right? So one thing that the Wall Street Journal article did find was that the data, there were instances of misattributed payments. So what that is it's a way to, it's an indication for someone that someone needs to look at that. Someone needs to call up that dentist and say, hey, what is this? Someone needs to investigate it further and then fix the data, if it's in your organization, right? I'm not calling up that dentist, though they do have his name in there, which is weird, but I've scrubbed all that. I could call the dentist. In fact, I should. The next time I give this talk, I'm having him on the phone. Explain yourself. So the next thing is food and beverage. So I thought it was weird. I looked at all of them, and food and beverage had one of the strangest ones. Someone's getting $70,000 in food. I want to know how they're partying. Much better than any of the parties that I've been at the Hadoop Summit in any of the years that I've been. But you see that this is, so the Wall Street Journal actually did call this person. They said, what's up with that? Because that's crazy. Like, evidently, even the reporters were shocked. And the guy said, I didn't get $70,000, and I don't know what you're talking about. So he could have been lying. I don't know. But the Wall Street Journal at least agreed with him. But I'm going to actually pause for 10 minutes of questions after a brief summary. But the idea here is that this is sort of a broader theme. My view of data science right now, and one thing that you can really do that's really effective, is you can pinpoint these things for humans to look at. It's not an automated utility to, the computer isn't calling up the dentist and saying, why do you have this money, this much in gifts, right? It's generally look at a human, have a human look at the report, look at the distribution and say, no, that's weird, and we need to call them. Because sometimes it's obvious. You can do further investigation and it's obvious. The other thing is, there's a 5-part blog series about this with much more detail, and I also did some Binford's Law analysis because we had financial data. And Binford's Law analysis is, financial data and a lot of natural data sets, the digits, the first digit and the second digit, actually all the digits, but in particular the first and second digit, have a particular distribution. And a lot of times they use and we know the distribution. So essentially the idea is that if for a given specialty, all of the data, or for a given specialty and payer, all the data is outside of that distribution, you can get a list of those and say, hey, this is weird. Right, and they do this for voter fraud, and it's a pretty standard financial analysis tool. So it shows you how to do that in Hadoop as well. So there's a 5-part blog series on my blog, which you can find on my website here, about that with much more detail. But ultimately, follow me on Twitter, email me if you have any questions. But I can stop now, and we have about 9.5 minutes for questions if you have any. Yeah, please. Please go to the mic if you don't mind.
Yeah, I was wondering if you could share any best practices you have around integrating this with production source control, version repositories, and things like that. One of the things we really struggle with is keeping the code in sync and visibility between those two environments.
Yeah, so IPython notebooks are interesting in the sense that, so what I would probably do is I put everything in the notebook, right? You saw a lot of helper functions there. I would urge data science teams to share helper functions and keep that in source control. Right, you're in a Python environment, there's no reason not to extract a lot of that code out and do that for source control. But even further, I'll take one step beyond your questions. How to productionalize this stuff? Right now, that's some of the challenges of the notebooks. How do you do multi-user? How do you do authentication? How does this all work, right? And there's not great stories around that yet, I would say. But that's coming very, very quickly, I would say. And the other thing is, the other question I always get is, I have Python, I want scikit learn version 3.0, and my colleague over here wants 2.0. And I always have to go to the ops team, and the ops team hates me, and they think I'm dumb. And I always have to explain to them, and I always have to end up explaining to them what a support vector machine is, and they get upset and frustrated at me. Right? Let's stop having to explain what support vector machines are to ops guys. That's why I think the Docker integration is really important. If you can build up the Docker image with all the libraries you want and submit it with the job, that's fantastic. And if you went to the talk yet, there was a talk yesterday about Docker integration. That's absolutely happening, right? There's a Docker container executor now, and that's going. The only challenge there is it's not quite supported with secure mode. But there's some challenges that we're getting there, is the upshot. The story is beginning. It's not there yet, but it's beginning. And you should feel free, if you have a small team, you can use this now, right, depending on how you're set up. But anyway, I hope that answered your question and more. Any other questions? Yeah, please, to the mic, please, if you don't mind.
So the problem I have is with my CS hat on, I love Python.
Yeah.
With my stat hat on, I love R.
I know. So hopefully we can help you with that, because as of Spark 1.4, they're rolling in Spark R, right? Okay, that's a mixed message, right? They're rolling in Spark R, but they're not expanding it to ecosystem. You could do this in Spark R, but if you want to run your favorite MLlib function, it's not there yet. Right, so the core APIs are there. Actually, I'm not even sure if they have the Spark SQL for Spark R, but it's beginning. That story is beginning as well. It's just not even as far along as that.
So just to finish it up with the previous question,
yeah.
You always, with R, you have the issue of all the packages and the package dependencies, so you have to make sure all that is going to get somehow set and productionized and repeatable, and hopefully the story is inclusive of that.
Yeah, so that's why I think Docker is important, right? I've been screaming about this for a while, and a lot of people talk about, well, you could package up a virtual env and put it on the distributed cache, and that just makes me very angry at the world. I don't even have to consider that. No, the Docker, being able to ship a Docker container with all of your dependencies that your team curates, and that you have multiple options, that is the way to go. But there are challenges with that, but it's getting there. I think that is the story. That's just my opinion. I'm not speaking for Hortonworks necessarily, but I as a data scientist who's in the field, I think that's the right answer. And it's happening. Yeah, to the mic if you don't mind.
There is a fine line, right, between the data engineering work and the data science work.
Yes.
Especially where you processing and creating source data for them to work on, and then there is this, this dance that will go back and forth, and some of the findings you're going to incorporate back into your apps. What is your experience in terms of that collaboration between the engineering side of the house and the science side of the house, and how we can make it more smooth and speed up the operationalization of the findings from the scientific research?
So in my experience, it's been poor. I think that there's too much of a wall. I'm a candid guy, so I'm going to tell candid things. Right? I think there's too much of a wall between data engineering and data science. I like to go back to the raw data. I need to go back to the raw data often, because the data engineering, the ETL, might have dropped data that I want, right? Or they might be a little bit too inclusive. I want to be able to see all the way back to the raw data. So that means I need to understand the transformations. So you either have to get a good way of communicating those transformations. And the ways that I've seen are things like Excel spreadsheets with source to target mappings, and that's horrible. And I've seen, the other way is to actually sit with the data engineer and to co-locate and to have cross-functional teams. And actually, I like data science cross-functional teams. I like that idea very, very much, and I don't see anybody doing it. I would really prefer that, because you have to know what the data engineers are doing. And you have to know, and it's really nice to have a solution all the way from the raw data all the way up to the application tier that's handled by various people. But that doesn't get you, it doesn't cheat the necessity for documentation. You have to document well and exactly, which means that you need to know where the pig script, you need a source of target mapping that's annotated with where were the pig scripts. You need data scientists who can read the transformation logic that the data engineers are doing. In other words, you see a lot about full stack engineers. You need full stack data scientists just as much as you need full stack engineers, in my opinion. I hope that answers your question. Yeah, please. Mike.
So you talked about the input of your data, and what about the output once you've done all these things in Python and your production language is Java?
Yeah, so IPython Notebook is for visualization and data investigation. This isn't running production. You're not going to spin up a Uzi job that kicks off an IPython Notebook and scrapes it. Though that would be awesome. I hope no one do that, but someone show that that's possible. No, what you would do is you would end up taking the data you would take the code that you're running in IPython Notebook, and then you would productionalize that. And that's either you could productionalize it yourself, or you hand off the IPython Notebook to an engineer. I mean, how many times have you handed off prototypes to an engineer to productionalize, and they're like, what the heck is this? This is at least, you can write a story there. You can at least describe what you're doing and have the visualizations there. And please, when you do that, show ways that the engineer can ensure that the output is what you expect. Maybe some tests, things like that. Hope that answers your question. Yeah, please, Mike.
Can you talk a little bit about security integration, specifically maybe with Active Directory or Kerberos? Is that type of support there in IPython?
Yeah, so I would say, I'm not sure is the answer. The way that a lot of people do this is they connect to the access nodes, or they have a special IPython notebook, server. They SSH in, so you're authenticated, right? You're running a secure cluster, or whatever. You spin up an IPython server and you connect to that port, right? There are other ways to do that with security and HTTPS and things like that. There does seem to be support for that. I don't know the details around it. There's two projects. One, there was a blog post done by Rackspace about how to create these IPython notebook environments for students in a class, right? I think it involved security, and there's a project to spin these guys up in demand inside of Docker images, right? None of those are great answers to that question, and not even answers to the security question. I think it's possible. I don't think a lot of people have thought about it deeply enough, put it that way. Any other questions? I have 1 minute left, then they're kicking us all out, or at least me. All right. Oh, yes. To the mic, if you don't mind.
So you mentioned that one requirement for the unified data science environment is that it can leverage the packages and machine learning libraries. So, but then why did you write the median.
Median absolute divergence.
Yeah, why did you
so
write
if
that
you'll
yourself?
notice in there, I'm leveraging. I'm leveraging NumPy. I'm leveraging, and in the full analysis where I'm doing Benford's law analysis, yeah, I'm actually leveraging SciPy and scikit-learn as well for doing distributional statistics, things like that. I'm using the fundamental tooling around statistics, right? I'm not using, in other situations I might actually use, more the machine learning stuff in scikit-learn. But in this particular example, it's using the machinery where I'd have to write my own median, I have to write some of these other numerical analysis stuff, but it just wasn't called for it. I had it available. Right. Any other questions? I think I'm done, so you can catch me after. Appreciate it.